We're going to pick up where we left off, and where we left off was old Earth, some of the evidence that suggests the Earth is old, and pick up now today with evidence that points to a young Earth. Again, it's worth reiterating, I'm trying to show it in a different way this time, but if this is the age of the Earth as far as today's evolutionists proclaim it to be, 4.6 billion years old, each one of these squares is 50 million years. And so that last one would represent the last 50 million years. And so if you were to take that last one and blow it up, now you've got another 100 squares, and each of these is 500,000 years. And so if you were to take the very last one of those and blow it up to 5,000 years, then this is the amount. So this is the tiniest corner of this, and all of this is the tiniest corner of that. It's trying to give you some idea of the magnitude of the difference between God's Word, what He says the Earth is, and what men, evolutionists, say it is. And they need all this time, because for the miracle of everything that's in the world around us, for it to happen by coincidence, by accident, they need a whole lot of time. Time becomes, in a sense, their God, and it works the miracles, but they got to have a lot of it. And so when they first started to talk about this, at first they increased the Earth age from what the Bible said to 50,000 years, and then a little bit after that it became 1,000,000 years, and then it was 5 and 10, and then they just went big, and I call it deep time. And what you're going to see is that kind of time has some liabilities with it as well, but those don't get advertised real well. So, quick review of the evidence for old Earth. First and foremost, if you ask someone, call them on it and say, well, how do you know the Earth is old? You weren't there. Everybody alive today wasn't there. Well, how do you know it's old? And they say, what most people will point to is geology, the features of the Earth and fossils. And as we've seen, all of that, all the geologic data and all the fossils are better explained by a global flood than eons of time. They might point to dinosaurs, and again, we would say that the evidence suggests that dinosaurs actually were contemporary. Most lived before the flood, and that's why we have fossils of some of them, is from the global deluge. But there is evidence that dinosaurs have existed after the flood and were known by Noah and his contemporaries. We looked at tree rings and ice cores and varves, and those maybe suggest the Earth is 10 to 15,000 years old, which is older than God says it is. Not that much older, though. It certainly gives no evidence of deep time. It tends definitely towards the younger side of things. They might point to radiometric dating. I would say this is probably the most common. And remember, radiometric dating is of volcanic rocks, and they look at the different radioactive isotopes that they hypothesize were cemented in when the lava cooled, and then it starts the clock and it decays, and we can measure its decay products and estimate how old that rock is, and so they come up with the big numbers of hundreds of millions or billions of years. But as we saw, there's huge data scatter. Samples from the same lava field can yield results that are literally more than 1 billion years apart. That might give us some cause. And there's also cases where we have turned in lava of flows. We know the age of that flow, and it comes up with, instead of 200 years old, it comes up with 200 million years old. So we know it's not really a reliable thing, but that is given great credence by the scientific community. We looked at carbon-14, which works for telling the age of organic living things. We'll come back to that later in this brief. And finally, it's starlight. And starlight supports deep time, just because we measure the distance of stars, we know how long it would take for light to get here. And that seems like it would take a very long time for it to get here. There are explanations for that, but this is the range of the evidence that what people who weren't there used to say the Earth is old. So a reminder, determining Earth's age is not true scientific. It's not repeatable. Okay, we can hypothesize all we want, but we can't go back in time and make the Earth go through all that it did before. And since nobody was there except one person, we got to just look at clocks. We look for natural processes that maybe give some indication. But all these calculated ages involve making three assumptions. Whether we're trying to prove the Earth is young or old, we look for clocks, and we have to assume that we know the starting time of the clock, what the clock was reading when it started, and sometimes that is a guess. We have to assume that the speed of the clock has never changed, or that we know the speed of the clock, and then we have to assume the clock was never disturbed. Something didn't break it or make it change and go the other direction. So these are always assumptions, and those are really unprovable. We can prove that the clock speed is consistent today, but we don't know if that clock speed changed due to circumstances some time ago. So just important to remember, all this evidence for a young Earth or an old Earth involves these assumptions. So it really is completely unprovable, but I just want to show you there are clocks that suggest the Earth is young. So here is the range of things that we, godly men of science have pointed to that suggests the Earth is young. So we're going to work our way through the highlighted ones. So there's 12 of them that I've picked out of the field, and we're going to briefly touch on each one. So this is a little more data intensive, but I still want to just show you what's out there. So the Earth's magnetic field. Some of you may know, some of you may not. There's a magnetic field. That's how our compasses work from this magnetic field. Well, that magnetic field, its purpose isn't so that our compasses point to north. Its main purpose is it actually deflects solar radiation that comes from the sun. And without that, life would not be able to exist. So it's a pretty important thing. But we've been measuring the strength of that field for a long time, almost 200 years. And what some men have noticed is the strength of that field is going down. It's decreasing. So there's our clock. And they measured that rate, and they kind of worked it back, and they said, you know what? This isn't going down linearly. This is going down exponentially. So let's move that decay clock backwards in time. And what you end up with is, if you move it backwards in time this way, you can only get back to a little more, about 20,000 years before the level of the energy of the magnetic field is so high that life could not exist. So we have almost 200 years of these measurements that give us, this point of the curve, and we can extrapolate it back to 20,000 years. And of course, we say, well, with Noah's flood, it could have done something that sort of changed it. So if we assume it started at the maximum possible energy, and we have no reason to think that either, but clearly the magnetic field points to a clock that says the Earth can't be more than 20,000 years old and is probably younger. So there's one. Another one, helium escape. So we talked about the radioactivity. When magma cools, it includes in it some often radioactive particles that decay. And one of the products of all radioactive decay is helium. And what do we use helium for these days for fun? Balloons, right? And what happens to those balloons after a day if it's a latex balloon? It goes flat because all the helium is the second tiniest molecule out there. Only hydrogen is smaller. And it's a very slippery one. It's a very stable one. Helium doesn't combine with anything else. Helium just likes to diffuse or escape. Well, when radioactive products decay, they release little helium molecules. And those helium molecules, over time, should escape out of a latex balloon. They come out of a mylar balloon. They come out of rocks. Helium likes to escape. So scientists in drilling deep holes have gone a few miles down into the earth into what should be really, really old rocks, billions of year old rocks, and they've pulled out these rocks, and they said there should be a small amount of helium from the current decay, but no more. But when we look at them, those rocks are full of helium. And that shouldn't be. We know how fast helium leaks out of the rocks and out of the crust into the atmosphere. It's a measurable thing. And so when you do that and you analyze, well, look at how much helium is in here, you can conclude that this rock is actually about 6,000 years old. So scientists, when I say scientists, evolutionists don't like that. That would destroy evolution. So they attack this and say, well, there's something about this rock that trapped more in. Or maybe it was between two layers that trapped things in. But, if there was two layers, what would a gas do? It would just go around the layers till it found a way and go out. So this is actually a pretty powerful piece of evidence that not much time has elapsed and why there's still so much helium trapped in these rocks. Similarly, this is a picture of the Earth's crust. There's crust that's full of radioactive material, which is producing helium. The helium, we know how much it diffuses out of the crust into the atmosphere, and it comes out of the crust into the atmosphere a lot faster than it goes from the atmosphere into space. And we know the rate at which it should be building up. And we can say, and what we realize is, all the helium that's in our atmosphere could be here in it would take no more than 1.8 million years. It could have got here a lot faster, but if we started with no helium in the atmosphere, all the leakage from the ground would have filled it up to where it's at right now in no more than 1.8 million years. Not 4,600 million years, 2 million years at the most. And there's plenty of ways you could say that there was already some helium or it leaked out faster, especially during the flood. You could easily come up with an explanation of how helium where it's at today is in 6,000 years as opposed to 4.6 billion years. So helium escape. Okay, here's one, erosion of the continents. So we know, just measured on average, that in 1,000 years, about 2.5 inches of dirt and rock, whatever, the rain and the wind and the ice causes it to little chips away and washes it down. In 1,000 years, about 2.5 inches will erode away. And of course, it depends on the soil type. In some places, that might be 5 feet. And in other places, it might be 1/10 of an inch of hard rock. But on average, across everything, 2.5 inches per 1,000 years. So if the Earth is 6,000 years, or we'll say 4,000 years since the flood, that's 10 inches, hardly noticeable, which is what we see. We wouldn't notice it. But if you have billions of years, that becomes a big problem. Evolutionists say continents are 2.5 billion years old. Well, 2.5 billion times 2.5 inches is 95 miles of erosion. 95 miles. So that can't be. How can that be? And so you throw that question to them. Well, they say the Earth is coming up, so it's eroding off and coming up. And then you can point to all the mountains and the features that they point to, and they'll point to it and say, those are 200 million years old. Like, well, wait a minute, how can that be 200 million years old? Because they should have all eroded in 200 million years. Easily eroded. So it's a big problem. Erosion, evolutionists originally pointed to erosion as that's how the canyons were made, and said, see, this is proof of old age, but erosion is actually more of a liability, because when you got to multiply that times billions of years, you end up with absurdities like 95 miles having eroded. So basically the continents as we know them today, would be completely flat down to sea level in no more than 19 million years. Of course, they're not flat and they're full of mountains, and that's because we believe that the world is only about 6,000 years old, and so we're talking a few inches that is unnoticeable. So, and now here's the other side of this. All of that erosion again, we know how much it is. It goes into the sea where it stays. What takes it out of the sea? What could take it out of the sea? Not much. So there's this popular theory, of course, that there's big crustal plates, tectonic plates, which I'm not sure is true anyway, but let's just give it to those that advocate for it. But these plates are sliding over and under each other, and so those might sweep some of the sediment out of the ocean and down under the plates. But maximum amount is about 1 billion, so about 20 billion tons a year going in, 1 billion tons going out somehow. Well, where is all that sediment? Okay, not a problem if the Earth is young, but so this is what we actually see. The average thickness of all that sediment on the bottom of the ocean, all that dirt and sand and whatever, is about 1,300 feet. Well, it wouldn't take very long to get to that at all. At most, 12 million years at current rates to get all the sediment that's at the bottom of the ocean. Of course, with Noah's flood, you could have got there a lot faster. So it's not a problem to say all that sediment could be there in 6,000 years plus a flood. But the big problem is if you've got to explain billions of years of erosion, where that sediment goes. If we had 3 billion years, that sediment should be 62 miles deep. Okay? And it's not there. Where is it? Where did all that erosion go? So you have to deny erosion, yet you go to any explanation of an old Earth, and they'll talk about, you go to the national park, and they'll talk about, oh, this eroded, and this rose up, and then the desert became an ocean, and then the ocean became a desert, and then the desert became a swamp, to explain. It's all these just so things. But in all of that, there's massive erosion going on, but there is no sediment in the ocean. No explanation for that. So we talked about carbon-14 dating again. And this is important to kind of understand this. Remember, a living thing, all living things, the sun hits the atmosphere, it turns carbon dioxide, some of it into carbon-14 isotope. A little bit of that is all through our atmosphere. Plants take it in, and they build up to a certain level of carbon-14, and then, and then animals come along and eat the plants. We eat the plants, horses eat the plants, cows eat the plants, we eat the cows. So every living thing has a certain amount of carbon-14 in it. But when that thing dies, no more carbon-14 goes in, and it starts decaying. We know the level at which it starts, or the level that every living thing has, and then the clock starts ticking once they die, and it starts going down, and it goes down at a known rate. So whatever is in that living thing when it dies, half of it will be gone in 5,700 years. Another 5,007 years, and half of that will be gone. So it's down to a quarter. And you can so on and so on. So if you know that starting point, and you can measure the current level, you can sort of say how old that living thing was, how far back when it died. So first, one assumption, again, I remind you, we assume we know what the level was. We know what it is today. We don't necessarily know what it was, say, before the flood. Could it have been different? Could the starting point have been lower? So when we get a result that suggests, say, that something's 17,000 years old because it's at this level, well, what if it only started at that level instead of that level? So it's not a conclusive proof of how old something is, but what we do know is after about, you can take this on 10 more iterations, so let's just say 100,000 years, whatever level it started at, it's all gone. Okay, more than 100,000 years, no carbon-14 is left, it is all gone. So how then do you explain these things that are assuredly millions of years old? Fossils, coal, and diamonds. In fact, diamonds, they say, are billions of years old, some of the oldest things on the planet. So nobody even thought to put those in a carbon-14 detector. So when some creation scientists did that, guess what they found? Carbon-14 in diamonds, in coal, in fossils. So that would say, if you believe that carbon-14 data, that suggests none of those are more than 100,000 years old. In fact, they're probably 4,000 years old, 4,500 years old when the flood happened. It's a very powerful piece of evidence that things that an old Earth person will hold up as millions of years is actually not very old at all. We've talked about this one before. Dinosaur bones, Tyrannosaurus rex, 62 million years old. Every book you read will put it somewhere in that range. 10 years ago, scientists cut open its thigh bone and found inside soft tissue. Biologic material. Blood cells, vessel wall liners, even some collagen, the proteins that make up connective tissues. There is no way that could last even 1 million years, let alone 62 million years, let alone even 50,000 years. 5,000 years? Maybe. If it was rapidly buried with no oxygen, then maybe you could have some tissue preserve itself. But there is no known process by which biologic material can continue to exist beyond a few thousand years. And so there it is. And that's not the only thing we find. Here's a fossil of a giant squid with its ink sac still somewhat preserved, and when they took analysis, that ink had organic material. It had melatonin in it. And the chemical consistency of that, by the way, is exactly the same as the chemical consistency of squids and cuttlefish today. And so evolutionists were like scratching their heads going, well, how, there was what? The ink never evolved after, they say this is 160 million years old and the ink never changed in 160 million years. Well, that's because it reached its optimal design back then, and so it never evolved any further. That's their conclusion. But organic material should not persist that long. It points to this creature was rapidly buried suddenly 4,500 years ago, and that's what's left. They went to some bacteria, some fossilized bacteria, and they looked in and said, wait, there's still DNA in this bacteria that's 250 million years old. We can't even fathom how far back that is, how old that is. And they looked and said, there's no way DNA should be in there, but there it is, which suggests that maybe that 250 million years is a bunch of baloney. It's actually relatively young. Okay, biology, population statistics. I'm going to pick it up just a little. People will say there's no way everybody that's here on Earth could get here if the version of Noah is true. That's 4,500 years ago. We have too many people who can't get there. It's not true. Very simple. We'll start here. Generation 1, 0, 6 people. Noah and his wife were too old to have children. So, his 3 sons and their wives. And we'll just say the population doubles every 150 years. And then we'll just keep on going every 150 years. So here we are today, 4,500 years later, 6.5 billion people. Very easy to get there. The actual doubling of a population is more like 40 years, not 150 years. Now, yeah, there's death, there's plagues, there's wars, but people have put in the formulas with those variables, and the point is it's very easy in 4,500 years to get from 6 people to 6 or 7 billion people where we are today. So I want to flip it on its head. Think about now if instead of 4,500 years, you have 100,000 years. You do this with 100,000 years, and you are going to have more people than there are atoms in the universe, which is preposterous, right? Think how many corpses there would be. Just the number. It just can't happen. Deep time, and that's not even deep time. That's 100,000 years. Humans have been around, they say, the evolutionists say, 1 million years. Think the massive number. Where are all the people? This is actually a problem for deep time. It is not a problem for a young Earth. The population data suggests that the Earth is not that old. Human history. Some of you may have seen this. This is a fascinating chart of all the civilizations. And this is the time span, the modern day, and this is the geology, or the continents of the world and all the kingdoms. But it always has fascinated me that the written, recorded history of all these societies and civilization only goes back about 2,000 years before Christ. You've got the Egyptian, you've got the Babylonian, Sumerian, you've got Chinese, and you've got the Hebrew Bible. Those are our 4 sources, and all of that starts around 2,500 years ago. There is the Egyptian chronology, there is some, piecing together, and some people have pieced it together in a way that goes back about 5,000 years, but that is definitely contended. But, the latest growing consensus is, of course, it lines up very nicely with the Hebrew Scripture, and so our recorded history only goes back about 2,500 years. Why would that be? Well, if you take the Bible's account, it makes perfect sense. Noah and his family grew and dispersed, became nations, they learned how to write, and they started recording, and we're finding bits and scraps of that. That makes perfect sense. But if the humanity is 100,000 or 1,000,000 years old, to think that all of a sudden people only started writing, 4,500 years ago, is, makes no sense at all. But that's what the data gives us. It suggests that we are young. Okay, a couple more. DNA mutations. So 2 parents get together, they have some children. Scientists have looked at them, looked at the DNA of the children, looked at the DNA of the parents, and said, on average, each generation, there is about 60 changes in the code. Remember, DNA is the building code, your instructions for you, for a human body, and it's mutating each generation. Just like everything else is decaying and winding down, the human DNA is decaying. And on average, it's about 60 mutations per generation. Okay, now if you go back to Adam, 6,000 years, it's about 200 generations. 200 generations from Adam to Christ, 100 from Adam to Christ, 100 generations from Christ to us today. So 60 mutations times 200 generations is not that much, right? That's 12,000 mutations times, out of 3 billion places of code. So 12,000 in 3 billion is not a problem. But if you take the evolutionist version that we are 1,000,000 years old, now you've got 7.2 million mutations, 72 million mutations, which is, a major chunk of the overall code and of the overall code. So as each generation goes on, and these mutations build up. Most of them are neutral, some may be harmful, but basically as our DNA goes down, our propensity to succumb to diseases and have problems and stuff keeps growing and growing and growing. So this says that there is a limit to how long humanity can go on, and it suggests that humanity hasn't been around very long because of this decay principle. Okay, final 3. Faint sun paradox. That's a catchy little phrase. Short version, our sun, as we see it today, it's getting hotter. A little bit each year. As the hydrogen fusion in its core goes on, it's getting hotter. Well, we know about how much it's getting hotter each year, so we can extrapolate that back in time. So if you go back 6,000 years, it's insignificant, it's trivial. But if you go back 4 billion years, the sun was so much cooler that Earth would have been an ice ball and no life could ever even have started. And so it's a big problem. Deep time, it's a big problem. That clock says the Earth can't be very old. If you make it very old, then you've got a frozen Earth and life could never get started. So how do they try to explain around that? They say, well, there must have been greenhouse gases around the Earth keeping it warm. But if that's true, there's no direct mechanism. So as the sun is heating up, why would the greenhouse gases go away? And if the sun kept heating up, the greenhouse gases would then cook everything. What would make the greenhouse gases go away as the sun is warming up? There is no linkage. It's just theory. They're just trying to explain this paradox of how the sun is changing. Okay, 2 more. Receding moon, same thing. We know that the moon, as it spins around the Earth, is actually moving away. Not very much, 1.5 inches a year, but it is getting further from the Earth. So let's dial that clock backwards, and you in 6,000 years, that's not very much. That's 700 feet, which is trivial in this distance. You wouldn't really notice it. But if you got to go billions of years back, the moon is actually in contact with the Earth, which is preposterous. It can't. So, in fact, long before it got in touch with the Earth, the tidal forces, or the gravitational forces between the two planets, the bigger Earth would have torn the moon apart, absolutely torn it apart. But of course, we would have had tsunamis thousands of feet high as it got closer. It's ludicrous to think of the moon being that much closer. And so that clock says that the Earth and the moon really can't be that old. Here's the final one, supernova remnants. So what's a supernova? It's an exploding star, and we do see stars from time to time explode. In fact, we see one explode about every 25 years on average. And then, you look at it in space, and a couple of them we've actually seen explode, and we see its pattern. And then it gets, over time, it spreads out more and more. So we can look at these, the residual that's out there, and we can say, okay, this one is a newly exploded, this is a old exploded, and they've created these 3 categories. Stage 1, it's about between 0 and 300 years old. Stage 2 is between 300 to 120,000 years, and then stage 3. Okay, so little experiment has been done. If the galaxy is billions of years old, we would expect to find about 2 first stage, 2,200 in the second stage of spreading, and about 5,000 in the third stage of spreading, really dispersed. Does that make sense? And if the universe is only about 7,000 years old, we would find 2 that have in the near, newly exploded, and 120 or so that are, more spread out, a little older. Okay, so what do we actually observe? 5, 200, and 0. Okay, old Earth, old universe says there should be about 5,000 of those out there. We can't find any. And their answer? Well, it's a big universe out there. We just haven't found them yet. But we found all the new ones and the medium ones, but we can't find any of the old ones. And oh, by the way, the ones we found here match better with 7,000. This just suggests that, the decay of the universe is a little more rapid than we, might have thought. But I think this, to me, is a very compelling one. This is a predictive kind of piece of evidence. Here's the rate we see. This is what we'd predict, and the evidence lines up with a young Earth. So, bottom line is there's only a handful of God-fearing scientists, and yet those few men, very underfunded, not compared to the millions and billions of dollars in universities and the thousands of scientists all looking for evidence of evolution, these handful of men have come up with some pretty compelling evidence that the Earth is young. Deep time is actually a liability, as you see. Things like sediment, erosion, the moon, the sun, all those things become massive problems when you got to do it over billions of years. But ultimately, no one can prove how it happened, nor how long ago. It's not repeatable. It depends on the accuracy of our clock. So all we can say, ultimately, there is only one eyewitness, and he gave us his testimony about how old it is. So that concludes today, and next week I could take a couple questions afterwards. I know we need to get going here, but But next week I'm going to try to bring it all together, the whole kind of what we covered all summer, and just give some of the highlights and tie it all together for you, and then that will conclude our summer series. So let's pray, and then we'll take questions. Father, thank you for giving us your testimony. Understanding where we came from and why we're here and what our purpose is profoundly important. And of course, more than that is, you have showed us what the problem is our sinful hearts, and the solution is your Son. So we thank you for your love for us, and so much that you sent your Son, and that you love us enough to tell us why we're here, what we're for, and that you want us to be saved and to be with you in eternity. And we thank you for that and look forward to that. In Jesus' name, amen.